Hello everyone, glad to meet you at Monster Scale Summit. Today I'm going to talk about how to overcome Redis scaling bottlenecks with EloqKV on ScyllaDB. So first, a quick introduction to myself. My name is Hubert Zhang. I'm CTO of EloqData. In past, I worked on many database products, including GreenPlumDB and Apache Hawk. Here is the agenda. I will first give a quick introduction to EloqData, and then talk about problem and our solution. Finally, I will give a brief overview of things to come in EloqDB. EloqData is a startup company building a next-generation database for the AI age. What we actually have is a new architecture to build a database. We are not going into technical details, but our key innovation is data substrate. It's a pluggable and modular database architecture. We can build different compute engines on top of data substrate and store data on different types of storage. ScyllaDB, in this case, can be used as a storage engine. You know, Scylla is a high-performance, distributed NoSQL database designed for low latency and high throughput workloads. It's an ideal option as a storage engine. Except Scylla, we also support other types of databases, such as Amazon DynamoDB and S3. We can get many key advantages by the previously mentioned architecture. The first is performance. The performance built with this architecture can match or exist the best-in-class solutions in many scenarios. The second one is modularity. We avoid reinventing the wheels to reduce the cost of building a new data models. The third one is scalability. Different resources in EloqDB can be scaled independently. For example, as your data increases, you can just scale your storage engine. You know, ScyllaDB as a storage engine has very good scalability. The fourth one is compatibility. You can use your favorite API from SQL, Redis to Mongo, and all the APIs are standard. Next is transaction. EloqDB is fully ACID transaction with cross-model transaction support. Finally, EloqDB is cost-effective by leveraging the tiered storage. Now, let's move back to the original Redis scaling bottleneck problem. Redis has many scaling issues. The first is data volume. Since Redis is pure in memory, it can lead to high costs for large datasets. The second one is scale-up issue. Redis is single-threaded, and scale-up CPU resources can not enhance your performance of Redis. The third one is scale-out. Redis is designed as a single node at first, so when you scale out, you have many trade-offs and it's full of pitfalls. For example, it doesn't support cross-node operation, and for big cluster, the gossip communication becomes expensive. Besides all the scaling issues, Redis also has some other issues. For example, Redis has bad transaction support. It doesn't support rollback and cannot make data durable. And Redis cluster doesn't support the cross-node transaction and also the Lua scripting. The next issue is client transparency. Redis and Redis cluster use different clients, so users have to modify their code when switching from single-node Redis to cluster mode. Moreover, Redis and its underlying store use different APIs. Applications have to do double write. Double write can further lead to the cache coherence issues. For example, you use MySQL to persist your data and use Redis as a cache. So when you double write MySQL and Redis, there could be a case that one succeeds and the other failed. This causes the data inconsistent between MySQL and Redis. EloqKV on ScyllaDB can resolve all the issues. So what is EloqKV on ScyllaDB? It is a high-performance, distributed transaction database with Redis API. Here is the architecture of EloqKV. There are three components. The upper left is a compute cluster, which serves as the Redis executor engine and the transaction manager. It also has a distributed buffer pool to catch the hot data. Bottom right is a log service cluster. It's optional. When you need data durability, you can enable log cluster. When compute node crashes, the new data may not be flashed into the storage cluster. EloqKV will recover this data from the log cluster automatically. The right component is the storage cluster. EloqKV stores data into separate storage engine. Here we leverage ScyllaDB cluster. You know, ScyllaDB is a high performance, scalable, and low latency. When the request data is not in the buffer pool of compute cluster, EloqKV will access ScyllaDB for a catch-miss read. As a result, ScyllaDB can provide the guarantee of read latency on cold data. We can also support other storage engines, such as Cloud KV cluster and Cloud Object Storage. Note that the new inserted data will not be flashed into the storage cluster like ScyllaDB immediately, but in a batch and async way. This is not only reduce the storage cluster pressure with batch operation, but also it can reduce the tail latency of the write operation. It will not affected by the LSM tree compaction and so on. Now let's review how Redis scale issues is resolved by EloqKV one by one. The first is data volume. EloqKV can leverage memory, local SSD, and object storage to auto-tier your data. For hot data, they are buffered in EloqKV. Distributed buffer pool, which can supply the ultra-low read latency. For cold data, they are stored in ScyllaDB, which serve the catch-miss read. EloqKV can also enable to use object storage to store cold data. In this setting, the local SSD becomes a cache of the object storage. Next topic is scale up. Different from Redis single-threaded worker model, EloqKV is multi-threaded and follow the thread per core model to achieve the best performance. This is similar to ScyllaDB, but we don't use the C-star framework. We benchmark EloqKV with Redis and DragonflyDB. Dragonfly is a state-of-the-art Redis alternative. The blue bar shows the performance of Redis, and the green bar is for Dragonfly, and the red bar is for EloqKV. As you can see, EloqKV is 10 times faster than Redis, and has very similar performance compared with Dragonfly. Note that Dragonfly is just a catch point solution, which means it is still a single node and doesn't support transaction. As I mentioned earlier, EloqKV is a full-featured transactional database. Scale out is another issue of scaling Redis. EloqKV can be fully scalable and elastic on all resource types, from CPU, memory, storage, to redo log. This enables you to scale the right component for your specific workload to reduce the total cost of ownership. The next topic is transaction. EloqKV is not only a cache, but a fully ACID transaction database. It achieves durability by using radial head log, and WAL is cross-AC. It supports different isolation levels, from repeatable read to read and read committed, and so on. It supports cross-node multi-ESEC and Lua scripting. Moreover, we also introduce a new Redis customer command to enable the explicit begin, commit, rollback semantics, which bring you the similar experience as you are using the SQL. Note that Redis is typically used as a cache. In this scenario, the client first reads Redis. If cache miss happens, the client needs to read the database to fetch a value, and then refill the Redis cache. But since EloqKV is a transactional database, it could be used as a primary database. The client is able to do read and write in a single database. Here we can see the left graph shows the durability performance of EloqKV compared with the Apache KV Rocks, which is a persistent Redis solution built on top of RocksDB. Both products enable the radial head log, and we run a benchmark on two types of disk, the cloud EBS and also the local NVMe. The blue bar shows the performance of KV Rocks, and the red bar is EloqKV. The result shows that EloqKV is also 8 times faster than KV Rocks. The right graph demonstrates the benchmark of distributed atomic operations. The blue bar is for the single node Redis, and the red bar is for the single node EloqKV. We can see EloqKV is 4 times faster than Redis. What's interesting, the orange bar is a 3-node EloqKV cluster, which means the distributed operations will include distributed transaction and remote request. But we can see from the result, the throughput of EloqKV is still higher than a single node Redis. EloqKV is a better solution to scaling Redis, but EloqDB is more than a key value store. Previously, we talked about EloqKV. Actually, EloqDB also supports multiple APIs. Besides EloqKV, we also have EloqSQL, which is a MySQL-compatible distributed relation database, and EloqDoc, which is a Mongo-compatible document store. We avoid reinventing the wheels by plugging the existing implementation of various open-source executor engines to guarantee the compatibility with the existing solutions. EloqDB is not just a copy of existing database, but brings much more features powered by the data substrate architecture. As we already mentioned, EloqKV has many nice features such as persistent storage, fully ACID transaction, auto data tiering, and cross-node operations. Let's see EloqSQL. When compared with MySQL, EloqSQL also has many good properties. For example, it is fully scalable with multiple writer compatibility, and it can reduce the cache miss rate by using the distributed buffer pool. Compared with Mongo, EloqDoc also has some features. For example, it can decouple the compute and storage, and has better distributed transaction performance. The above 3 individual products shows the features of EloqDB. So what's the next? I will preview our Eloq data converge DB. But before that, I will first describe the AI problem. You know now it's the AI age. Here is an example of how to build a financial AI agent application. There are 4 agents. They all need to consume different kinds of data which are stored in separate databases. For example, use PostgreSQL to store tabular data, Mongo to store document, vector database to store embedding, graph to store relationship, and use ES to store the full text index, and so on. It has many pain points. Firstly, there are too many databases, which is hard to manage. Second, and more fundamental issue, is that we cannot do the cross-model transaction, or we cannot query across a database in a unified way. For example, a single financial report may need to be stored across different databases. The original format is stored in Mongo. The embedding is stored in vector database, and the relationships are stored in the graph database. Writing the same data separately into multiple databases can lead to inconsistencies. For example, if a document is successfully written into the Mongo but failed into the vector database, this document becomes unsearchable via the vector index. So how to solve the issue? Here is our vision. We propose our converged DB solution, a unified database powered by the data substrate. It integrates multiple data models and enables the cross-model transaction. It also supports the standard API for users to quickly migrate their applications. ConvergeDB also reduces the number of databases to manage, which is very cost-effective. We are very happy to announce the EloqDB is open source. We open source EloqKV, EloqSQL, and EloqDoc at the same time. Welcome to join our community. You can also download our software from the website. We will release our cloud product in the near future, so stay tuned. Thank you very much.